Today I'm going to discuss about branch, node, junction point and nodal analysis technique. So before that, what is branch? So let us consider one circuit here. In this circuit, two loops are having, that is loop 1, this is loop 1 and this is loop 2. Okay, loop is nothing but closed circuit. So here in this loop, we have connected with resistors and voltage sources. For each for each element, we are indicated with two variables, two names, that is AB. For this one, this resist R2, it is BC. For R3, it is CF. For voltage source, here voltage source is there, V2 voltage source. For this, it is for V2. Okay, and resistor ED, DE, EF, like that. Okay, here what is branch? Branch is nothing but it is a part of the network. Okay, it is part of the network which connects the other points of the network. Okay, so this is the branch here. This will be acting like a branch. Okay, this branch is connecting with the other points of the network. Suppose this is the point B and point A. Okay, it will going to connect with other elements. So here R2, this R2 is connected with this point and point C. Likewise, R3 is connected with point C and point F. Okay, part of network which connects with other points of the network. Then it is said to be a branch. Suppose in the circuit, if you want to know about how many branches are there, okay, how many branches are there, by making use of this formula, we can tell that how many branches are there in the circuit. See, let us see B is equal to n minus 1 into plus L. The formula is n minus 1. This is plus L. L indicates here, this L indicates number of loops. How many closed loops are there? This is loop 1, loop 2. Number of loops are 2. And nodes, n is the node. Node is nothing but the intersection point of two branches. Okay, this one, point A, point B, point C, point D, point E, point F. Total 6 points are there, 6 nodes are there. 6 minus 1 plus 2. Okay, 6 minus 1 is 5 plus 2. 5 plus 2 is 7. Total number of branches is 7. You can see here numbers. AB is one branch, BC is another one, CD, DE, EF, FA and FC. Total, if you count, you are going to get number of branches as 7. Now coming to node, what is meant by node? Okay, node is nothing but here in this minimum condition will be there. Minimum is 2. Okay, minimum 2 or more branches meeting at one common point. 2 or more branches, minimum condition is 2. Okay, so if you see this, AB is a branch and BC is also another branch. This branch, two branches are meeting at point B. This is a common point, so this common point we can call it as a node. Okay, so likewise you are having different nodes. So how many nodes are there? The condition is minimum 2. So likewise, if we see that total we are going to have 6 nodes. Already in the branches we discussed, the 6 is the number of nodes, that is point A, point B, point C, point D, point E, point F and point A. Those all are called as nodes. Okay, now let us discuss with the junction point. Okay, the junction point and node both look similar, but the thing is, in junction point the condition is minimum 3 more 3 point. Okay, minimum 3. In the node we have said that 2 branches is the minimum condition, whereas in the junction point minimum 3 branches must meet together. Okay, minimum 2, 3 or more, so must meet together, then it is called as junction point. So you can see that point AF, sorry, branch AF and CF branch and EF branch all are meeting at point F. You can see the cursor. This is the point F. So this is acting like a junction point. Okay, this is acting like a junction point because 3 branches are meeting here, not point A, because for point A only 2 branches are meeting here. Okay, similarly point C is also a junction point. Okay, total how many junction points are there in the circuit? In this circuit we are having only 2 junction points. Okay, so here junction point is also a node itself, but not all junction points are nodes. Okay, because here we in the statement only said that two or more branches, more is nothing but three also comes into picture, no? Two or more, okay, two or more, or three more means three or four or anything, no? Okay, that is the thing. So every junction point is a node, but not every node is a junction point, yes or no? Okay, so let us go with the nodal analysis technique. Let me clear all these diagrams. So junction point we discussed only C and 2 endpoints. Okay, let's see that nodal analysis. What is actually a nodal analysis? In this nodal analysis, what happens is we are going to get the response. Okay, we need to find the response of given circuit. What is meant by response? The response means in order to find the either voltage or current in the given circuit. Okay, we can find voltage or current in the given circuit. So in this nodal analysis technique, this is a technique. Okay, this is a technique where we are going to find the unknown voltages and unknown currents. How you will find unknown voltages and unknown currents? By making use of Kirchhoff's current law. Okay, so this is very important. You have to note that we are in the nodal analysis technique, we are going to apply Kirchhoff's current law, that is KCL. Okay, in this case, okay, let us see that some steps you need to follow. Okay, first thing is I already mentioned that KCL you have to follow. Second thing is that you have to apply junction point as a node. Okay, you have to identify the nodes first. Okay, node in the sense here 2 points, no? But don't consider here in the here we on the statement I mentioned that every junction point is a node. So in the nodal analysis technique, we need to consider the junction points as a nodes. Okay, nodal analysis nodes. Okay, name indicating, no, nodal means nodes. So first thing is you have to identify the nodes. How many nodes are there? Node means nothing but a junction point here. Identify the nodes here. After identifying the nodes, whatever the nodes we have identified, for that nodes we need to give some voltages, the unknown voltages. Okay, those are the unknown voltages are indicated with V1, V2 and so on. And the thing is, in the circuit, one junction point will be there, no? So above in the circuit, let us see this circuit V1, this is the junction point, and this is also a junction point. V1 and V2 are the names given, and here the down all are connected to one point, no, common point only, no, all are connected to this zero potential. So that is also a node itself, because 1 2 3 4 are connected, all the four are connected to this line. So we can say that it is also a node itself, that means junction point itself. And for this you need to give always V is equal to 0. Okay, V is equal to 0, that is very important, that this is also a one node. So in the equation, how many in the circuit, how many nodes are there? 1 2 and 3. Okay, in this three nodes are there, we are going to get 3 minus 1 equations. That is, if n nodes are there, we will get n minus 1 nodal equations. Likewise, 3 nodes are there means 3 minus 1 nodal equations, that is 2 equations we are going to get. Okay, from that 2 equations, by just taking in the calculator, okay, 2 equations we are going to get. 2 equations means 2 unknowns will be there. 2 unknowns can be calculated in the calc by taking the coefficients of those variables, whatever the variables are there, for that coefficients will be there, no? So by substituting that coefficients, we are going to get the values. Let us see this circuit, very simple circuit I have taken. The same circuit I am writing the equations. The procedure is, for the circuit, the first thing you need to give the nodes. Okay, first you just make dot marks on that one. After making that dot marks, see I am placing cursor on it. This is the dot 1, dot 2, dot 3. Okay, this dot, for these dots So how dots are identified? Because this current source, this resistor and this resistor all are meeting at one common point. So this is a junction point. Here also resistor and these two are in connected in series ma. So only one branch we have to consider. This R4 is connected. That means here it is only 3. The condition is 3, no? And don't consider R4 and R5 as one point, node point, because we are considering junction points in the circuit. So V1 and V2 will be the two nodes, and this V is equal to 0 is the reference node. We can call it as datum node. Okay, reference or datum, DATUMN, datum node, whose potential is always 0. So whenever you are applying Kirchhoff's current law for this nodal analysis technique, you need to apply KCL, no? So always assume that whatever the nodes which we have assigned, we don't know the values of voltages, no? Do you know V1 and V2? So we just assumed that values. So when you are assuming that values, you have to think that voltages are the highest potentials. Okay, voltages are the highest potentials. If they are highest potential, what about the currents? So we know that current flows from higher potential to lower potential. That means from node 1 all currents are leaving. Okay, if there is no current source, all currents will be leaving. If there is any current source for that node, okay, if there is current source entering towards the node, don't change that one, don't change the direction of current. If there is no, if the direction is downwards means downwards, if the direction of current is upwards means upwards. But okay, if for the resistors, if the resistors are connected, always currents will be flowing from higher potential to lower potential. When you are assuming for at node 1, when you are, suppose if you are assuming a node 1 equation, so V1 will be the highest potential, because the ground one is 0, no? So from V1 it is going where 0 potential. Okay, so that's why I2 is indicated downwards. Here in the circuit, I1 is entering current, don't disturb that I1. I2 will be downwards. Okay, similarly I3 will be from where it is going, because we don't know the value of V2, no? So let us assume that V2 is lower potential compared to V1. Okay, so in the step 1, I3 direction will be from V1 to V2. But when you're writing for step 2, that is nodal equation 2, you have to assume that V2 will be acting highest potential. Okay, so then I3 direction will be reverse. Okay, we don't know actual current of I3 value. So actual current here I'm taking two directions. One direction is from V1 to V2 as I3. Another direction, when you are writing for nodal equation 2, I am taking the direction from V2 to V1, two directions. Okay, and the magnitude will be same, and the direction, which direction actually the current flowing, can be obtained after knowing the voltages. We don't know the values of V1 and V2. Okay, after solving the voltages, then we can say that, suppose if V1 is greater than V2, we can say that current will be flowing from V1 to V2. Suppose if V2 is greater than V1, we can say that current is flowing from V2 to V1. Likewise, we need to consider. Okay, let us write the nodal equation for first node. So first node, how many currents will be there? Three branches are there. Okay, I1 is entering, current source is there, don't disturb the direction. I1 is towards the node, whereas for R2 and R3, we are assumed current directions are leaving, that is I2 leaving and I3 is also leaving, because V1 is the highest potential. So that's why we know that KCL, current sum of currents entering is equal to sum of currents leaving. I1 is entering current, I2 and I3 are leaving currents, I2 plus I3. Okay, so I1 is I1 itself. In the place of I2, I can replace it by voltage, no? So we know Ohm's law, I is equal to V by R. What is I is equal to V by R, no? What is V here? V, from this I2 current, from where it is going, from V1 to V only, no? V1 to V1, from the position of V1 to the position of reference voltage. So the potential difference we need to consider. The 2 points. What is the potential difference? Highest potential is V1, lowest potential is minus V. So where, what is the value of V? It is 0. No need of writing the value. I am writing just simply V1, and R is resistor is R1. Now for I3, how you will write? For I3, from you can see that I3, from where it is going, I3 is not going to ground, no, I3 is going from V1 to V2 position. That's why highest potential minus lowest potential, V1 minus V2 by R2. Now I am going to separate the coefficients of V1 because V1 is the unknown value, V2 is the unknown value. I am writing V1 coefficients outside, 1 by R1 plus 1 by R2 minus 1 by R2 V2. Okay, coefficient of V2 is minus 1 by R2. That is equation number 1. Now, similarly, I can apply nodal equation for node 2. Okay, same thing. Here, is there any current sources? There are no current sources, and you see that from V2, the current through R4 and R5, R4 and R5 are connected in series because no other circuit is connected over here. So only single path is existing. So whatever the current flowing through R4, the same current will be flowing through R5. Okay. So how many currents will be there now from node 2? So this is V2 is acting like highest potential now compared to V1. Previously V1 is the highest, greater value. Now these are all our assumptions only. We don't know actually. Okay. So that's why V2 is acting highest potential. We are considering, we are assuming. So V2 is highest potential means three branch currents will be leaving. That is I3 will be from V2 to V1 and I4 will be from V2 to the ground potential V equal to 0 and I5 will be from V2 to ground only. Where it is going actually, this I5 current will be flowing to the ground only, no? So I5. So is there any currents entering towards the node? There is no current entering towards the node and all the currents are leaving from the node itself. So sum of currents entering is 0 and sum of currents leaving, what are the, that is I3 plus I4 plus I5. Okay, so that's why I have written here I3 plus I4 plus I5 is equal to 0. So if there are no current sources, what you have to do, you have to replace it by Ohm's law, that is I is equal to V by R. What is V? V is nothing but potential difference. Potential difference means 2 points you will be having, difference means 2, minimum is 2. So I3 where it is going, from V2 to V1. So that's why I have written here I3 is replaced by V2 minus V1 by R2. Previously I have written V1 minus V2. Now I am writing V2 minus V1. Okay. So finally we can get that which is V2, which is V1 after knowing the voltages. Okay. Now what is I4? I4 where it is going, from V2 to 0 only, no? So 0 it is no need of writing V2 by R3. That is why I have written. And I5, if we see here, these two resistors are connected in series. So we can add this R4 and R5 branch. So we can write V2, this is 0 only, no? Potential difference, V2 by R4 plus R5 is equal to 0. In this equation, I can separate the V1 variables and V2 variables so that I can substitute these equation number 1 and equation number 2 in the calci. I will get the values of V1 and V2 exactly. Okay. So V1 quotient is minus 1 by R2 and V2 quotients, how many are there? V2 here, here, 3. Okay. 3 values will be there, 1 by R2 plus 1 by R3 plus 1 by R4 plus R5 into V2 and the current is 0. Okay. No current source. So by solving 1 and 2, we will get the values of V1 and V2. Okay. This is the procedure. Thank you all of you.